Hey everyone, welcome back to NDC, and in this episode, we're kicking things up a notch by learning how to think like a programmer. We're going back into Learn to Code 1 for the final lesson, algorithms. So don't worry, algorithms is just a fancy word for a step-by-step plan to solve a problem. Whether you're guiding Byte through tricky terrain or planning the perfect move, algorithms help us write smarter and cleaner code. We'll break down what makes a good algorithm and then test our logic in a set of these fun, hands-on puzzles. By the end of this one, you'll be solving challenges like a coding pro. Are you ready to get started? Let's dive on into algorithms, one step at a time. So an algorithm is a set of rules and instructions you need to solve a problem. For example, a navigation app uses an algorithm to find out the fastest path of where you want to go, from point A, your starting point, to point B, your destination. So here we have, avoiding traffic. So here it's going to compare the different traffic conditions and select the route with the shortest travel time. We can see here, one's 25 minutes, another 35, and this one 18. It's going to say, hey, this is the fastest route to get to you where you need to go. So suppose we need to direct a car to be able to find a parking space. What instructions and rules could we use to move the car around the building? If we were to create a while loop and say, hey, while you're not in a parking space, drive forward, it may drive off forever. It doesn't tell the car to turn at the end of the building. So we can expand upon this while loop. So to move the car around the building, we're going to create a rule to repeatedly check whether it's being blocked on the right, just like we were doing before with the while loops. We can see that if the car is not blocked on the right, it's reached the end of the building and it should turn right. We're not quite done yet. As we saw, the car just kept turning right. We need to tweak the algorithm a little bit more, and part of creating algorithms is this trial and error. So after turning right, the car should drive forward and then go around the building, and we've found that parking space. So a lot of code that we've written so far has been instructions to solve problems. We've been actually writing algorithms this entire time. The thing we're exploring today is the process of writing and tweaking code so we can use it in different situations. All right, we are starting off with the right-hand rule. We're going to use the right-hand rule algorithm to navigate around walls. It seems we have some walls and some gems that we do need to collect. We used blue last time. I think I'm going to swap on over to maybe Byte again. I think Byte's my homie. I do like Hopper too, but let's use Byte for this one. All right, so it wants us to run this puzzle, and notice how our character stops after the first gem. Let's go ahead and also do the step through code so we can see how it's working with the sample code. So while we're not on a gem, it's going to call upon this function, navigate around the wall. And the navigate around the wall function is basically checking to see, okay, are we blocked on the right? We're going to move forward. Otherwise, we're going to go ahead and turn right. So see here, we're no longer blocked on the right. So we're going to turn right. We'll then move forward. Are we blocked on the right? Move forward. But we stop when we get to the gem. So to solve the puzzle, we need to tweak the algorithm, but it also suggests, maybe writing some pseudocode, or maybe even, in my purpose, we'll talk it out a little bit. So based on the pseudocode above, where it's kind of just giving these instructions in plain English, we should write out a solution in code for the puzzle. Okay, so we have our navigate around wall. I don't think we need to tweak this. I think the part that we need to tweak is the while loop, which is more of the algorithm part. So it's suggesting while not on a closed switch, navigate around the wall. If on gem, collect gem, and then turn around. So how can we turn this into code? Luckily, our command names or function names are very similar to what they should be in English. So instead of being on gem, it suggests that we do not on closed switch. We know that the exclamation point means opposite, so we can do is on closed switch with the prefix of the exclamation point. This basically says, while we're not on a closed switch, just like it suggests, navigate around the wall. Perfect, that is the name of our function. We can go ahead and leave that there. Next, it says if on gem, so we can use an if statement, and we can use our condition of is on gem. we'll want to collect the gem. Let's go ahead and put that between the braces. Select gem, and then it suggests that we turn around. Well, we can do that by turning our character twice, basically rotating 180 degrees. So let's do 2 turn lefts. Now it also suggests here, outside of all of the code, it suggests that we toggle the switch. So let's go outside of our braces, and at the very bottom, let's toggle switch. So based on this pseudocode, as in speaking in plain English, giving instructions, we've turned that into different blocks of code. Let's go ahead and step through our code and see how this works. So we're going to say we're not on a closed switch. We're going to go ahead and run this while loop. We're going to navigate around the wall. Also checking if we're on a gem every single time as well. And we're checking our function again, move forward, not on a gem. Okay, go back to the function. Are we blocked on the right? Nope, so we're going to turn right and move forward. Are we blocked on the right? We absolutely are. We're going to move forward. Are we on a gem? Collect gem. We're going to then turn left twice, essentially turning our character around. So you can see by giving these instructions and turning into code, we're able to create this algorithm, kind of solve this puzzle and then put it into code. I'm going to speed it up a little bit because we know our logic works, but I am curious to see if our logic with the switch will work, because essentially, while we're not on a closed switch, we're running this code, and then finally we'll be on a closed switch and we'll toggle it. There we go. So by writing a set of instructions and rules to follow, we created that algorithm. So next we're going to see if a similar algorithm works in a slightly different puzzle. We're going to go to the adjusting your algorithm challenge. Okay, so we have a very similar puzzle in the sense of we have additional blocks that are around the different walls, and these prevent our right-hand rule algorithm from working properly. Before, we just kind of had these walls that jutted out, but now we have walls that kind of are in this L shape where they have multiple corners that will make our navigate around wall not work the way that's expected. So we even have some pictures here. We need to adjust our algorithm to deal with these situations. So if we're blocked on the right and front, if we're blocked on the right, and we need to handle the case of when we're not blocked. Also think back to our coding toolkit and think about what tools that we want to be able to handle. The first thing I'm thinking of is this and keyword, blocked on the right and in front. Do we remember the operator for and? We can create an if statement that says if is blocked on right and is blocked. Is blocked basically just means if we're blocked in front of us, we handle it there. We also need to be able to handle if we're blocked on the right. So we can use another if statement there. And then if we're not blocked, we can keep that else to turn right and move forward. So what I'm going to do is in our function, I'm going to create a new if statement. I'm going to say if is blocked right. And, so we're going to use double ampersand, is blocked. Just the normal is blocked, which means if we're blocked on the right and in front, we're going to add our brace and hit return. What do we want to have happen? Well, in this case, we can even see in this little diagram, might be a little bit hard to see, we need to turn left. Cool. Now, when we have multiple if statements, we need to be handling them appropriately. This means that we need to say if, else if, and then finally else. So we'll say else if blocked right. Then our final case, if neither of those are true, we will then do that turn right and move forward. Do we need to make any changes to our while it's on closed switch? I don't think so, but we can always go ahead and make those changes as we see fit. So let's go ahead and run our code with the step through and let's watch a byte. Oh, and something I didn't know is it actually changes the environment every time. We still have those different patterns. So we'll get to a situation where we'll be blocked on the right and in front of us, and we'll see if our logic works. But it's pretty cool to be able to talk through the solutions and then put them into code. All right, we're going to then navigate around the wall. We're going to turn right and move forward. Now we're blocked on the right still, so this should cause us to just move forward. Correct. Now we're not blocked, so we're going to go ahead and turn and move forward. So coming up is where we're going to be blocked in front of us, and we're going to be blocked on the right. So let's see if we made the correct choice to turn left. This is our new if statement right here. So we're going to turn left. There we go. Now we're going to navigate around the wall. We're only blocked on the right. So we're going to move forward. We're going to check, are we blocked in front or on the right? Nope, so we're going to turn and move around. Okay, this looks like a pretty long puzzle. We've verified that most of our logic works, but I want to double check that we can collect the gem properly before we put this on fast forward mode. I think with these larger puzzles, oh, we just teleported. I don't know what that was about. That was interesting. You know, sometimes the playgrounds they have some glitches. That was interesting. Sure, Bite. Sure. Let me know if you did this puzzle and also teleported. I'm gonna change it to be run faster so we can test our logic a little bit more quickly, but I think we've got it. We're gonna pick up the gem, we're gonna turn around, navigate around these walls. Look at us go. And then finally, we should be able to toggle that switch. Awesome. So we've tweaked that existing algorithm. We even had steps from our previous one, and we made it work for different circumstances. This is the real power of code, creating programs that solve problems in many, many different situations. Your map may even look different from mine. Alrighty, conquering a maze. So we're going to use the right-hand rule to navigate through the maze. So we need to imagine if we always keep our right hand on the wall, we'll eventually reach the last gem. So to solve the maze, we need to adjust our algorithm from the previous page to navigate the gem and collect it. So we can either start by copying and pasting from our previous page, or if we want a challenge, to start with all new code. Honestly, I think it's fine to just work smarter, not harder. We've already written it. So you can navigate to the other page by opening this left tab here, or using the back arrow. So we're going to scroll down to our code editor. I'm on Mac, so I'm just going to highlight everything. You can do the same for our iPad to select all of your code. There should be a little option if in your iPad to select all, as well as copy. Otherwise, I'm going to right-click copy or Command-C. I'm going to go back to conquering a maze, and in our code editor, let's go ahead and paste that in. Okay, so the first thing, and let me just double check, because there may be things hidden behind walls. I don't notice a close switch. So all the previous times we've been using a close switch to get us to the end. This time, that's not the case. I think the first thing we need to do is adjust our while statement to say while is not on gem. So instead of while is on close switch, we'll do is on gem, leaving the exclamation point to do the opposite. So while we're not on the gem, we're going to navigate around the wall. I don't think we'll need to turn left and turn around as there's only one gem. And we can probably remove this if statement because we'll want to use the collecting of the gem to actually exit this while loop. So while is not on gem, and then when we're finally on gem, we'll go ahead and collect the gem, just how we were using this toggle switch at the bottom. And we can go ahead and delete that too. Alrighty, let's go ahead and see if this is the correct solution. So we're going to call upon our function. Are we blocked right? Move forward. Yep. We're not on a gem. Go back to the function. Are we blocked right and forward? Nope. Are we blocked on the right? We are. So even if there isn't necessarily a huge wall blocking us vertically, any of these dips here, even like here where we're going to be with the water, you'll notice is blocked right and in front of us does trigger because we can't move down there. There's no stairs to help us get down. We're going to be blocked in front of us, and we're also blocked on the right. We can't go in that water. Okay, it looks pretty solid. I just hope that we don't end up in like an infinite circling loop. But we can see that our algorithm so far is handling everything very well. We're going to be blocked in front and on the right again. This is the big part, but we're only blocked on the right. Should be able to move forward. Okay, I'm gonna speed it up a little bit. I'll just do the run faster and we'll see if we do end up getting blocked anywhere. Otherwise, I think our algorithm is pretty much good to go. Oh, I say that and then this happens, but hold on. There we go. Okay, that got me worried for a moment, but we did a little turnaround there. And we collected the gem. Wow, okay, so by tweaking our algorithm, all we really had to change was the condition. To make sure that we reached the gem, there was no switch this time, we didn't have to collect multiple gems, but our function still worked. It allows us to navigate these puzzles and eventually reach the end. Let's see if we can now generate algorithms to solve even more scenarios. And this time, we're writing our own algorithm. We don't have a kind of placeholder to get us started, and we got some interesting things going on here. I wanted to see real quick if these switches change states. Okay, looks like everything remains the same. You sometimes never know with these puzzles if they're going to be giving you ones that update every single time from scratch. We're going to walk through pseudocode in our mind for how to toggle the 6 switches and reach the gem. We're then going to write our code and adjust the algorithm as necessary. First thing I'm noticing, just like with the last playground, there's only one gem. So I think this might be for our while is not on gem. Let's start off with that. Let's do our while placeholder here, and we'll say exclamation point is on gem. And while we're not on the gem, what do we want to have happen? Well, we definitely need to move forward. That's step number 1. There's lots of movement we have to do. But what about for the cases when we're on a close switch, right? We need to be able to handle those as well. So above our move forward, let's create either an if or a while loop. I think we'll use another while loop because we're going to be wanting to repeat this motion over and over again. So we'll say while, and then we're going to be like not on a close switch. So exclamation point is on close switch. As well as we want to make sure that we're repeating this while we're not on a gem as well. We'll do our double and exclamation point is on gem. And this is where we're going to be using our move forward. Let's go ahead and drag this up within those braces. So when we're not on a close switch and while we're not on the gem, we need to be moving forward and going through this puzzle. We can then look at some if conditions. So after the while, but still within the main while, outside of the nested while, let's go ahead and create those conditions for when we're on a close switch. So if is on close switch, go ahead and add our brace here. We want to toggle the switch. Is there anything specifically we need to do after toggling? So let's say we toggle this first one. We would need to turn our character. So we'd probably want to turn right. So we'd be here, we'd turn right, move forward, but then we encounter a wall. But we can handle this case, because what if we're blocked and on a close switch, we need to turn left. Look up here. If we're blocked and on a close switch, we need to turn left. Oh, okay. Okay, I think I'm getting it. So if we're on a close switch, we can toggle the switch and then turn right. And then we can write an else if is on close switch and is blocked, right? So when it's in front of us, we'll then want to toggle the switch and then turn left. And then very finally, we're going to go ahead and select the gem. Okay, this looks pretty good. I think there might be an issue, but let's go ahead and run it and see what happens. And it's okay that if you don't get it right the first time, a lot of this is, kind of figuring things out. So we're not on a close switch, we're not on a gem, we're going to move forward. We're now on a close switch, we're going to toggle, and we're going to turn right. So we're not on the gem, we're on a close switch, so we move forward. So if we're on close switch, it's going to toggle it and turn right. That's not exactly what we were after. Go ahead and stop the bite for a second here. So this is where the ordering of our if statements, and this is what I was fearing would happen, ordering of our if statements matters. Because when we look at our if statements, it's going to say, okay, if is on close switch, and we were on a close switch. So we never needed to get to this second part here where it says else if is on close switch and is blocked. So we need to just change the order of our code a little bit. We need to put this, where we're checking for both conditions, in front of the other if. So let's go ahead and move this above. And we're going to take this else, and we're going to put it in front of this one. So now it should check if it's on a closed switch and blocked first before checking if it's on a closed switch when we're not blocked. Let's go ahead and run it again so we can see this logic in action. Okay, so we're not on the gem, we're gonna move forward. Okay, so we're on a closed switch, we're not blocked, so we go to the second, the else if. Now when we move forward a little bit more, we're gonna check. Okay, are we on a closed switch? Are we blocked? We certainly are. This is the one we're gonna turn left. And it should happen again up here. Okay, we're going to be on a closed switch and we're blocked, toggle it, turn left. And then as we move forward, we'll see we're not blocked in front of us here. We'll probably be blocked in front of us here because we can't fall off the world. So our algorithm should be able to handle these scenarios. I'm going to speed it up again. We can run it a little bit faster. So we're going to turn left here because we're blocked. We don't want to fall off the world. And we're going to turn left here again, not falling off the world. And then we're finally going to be on the gem. We're going to exit that while loop and then collect it. Awesome. We've created our own algorithms. That is indeed pretty cool. And welcome to our very, very last challenge. Roll right, roll left. Look at all those check marks. Oh my goodness. So much coding. So much amazing coding. This is the last challenge of Learn to Code 1. And we're going to test all of our skills that we've learned so far. Holy smokes. So we got gems, we got closed and open switches. Nope, no teleporters though, no teleporters. Let's just verify. Okay, it doesn't regenerate every time. Let's think about this. So we get blocked here. We're gonna be blocked here. Okay, so every time there's these two gems, there's something blocking us, whether it's the rocks, the wall, lack of wall. So that's a good hint with the gems. And we do have a toggled switch at the very end. I believe this closed switch is going to be the answer for our wow. Something to keep us moving through, just like the gem and switches have been for us before. So I think we're going to start off our while loop and we'll say, while we're not on an open switch. So is on open switch. What do we want to have happen? Okay. So we definitely need to be moving through this playground. And I know the first step we definitely need to do is move forward. So let's go ahead and add that move forward. Okay. So the first encounter is going to be a gem. Every time we get to the gems, we need to collect them. And we need to turn right, move forward, and collect the second gem. When that happens though, we're no longer going to be on a gem. So we'll need to handle another case for when we're on the switches. So let's do our first if statement before we get too ahead of ourselves. So while is on gem, we're going to go ahead and collect the gem. We'll then want to turn our character right, move forward, and collect that last gem. So we're going to collect both of those gems. Okay, so the next condition we need to take care of, what if we're on a closed switch? We can see here we have a few pairs of these closed switches. So if is on closed switch, what do we need to do? We have these repeated patterns just like we have with the gems here. Well, we'll definitely want to toggle the switches. And then we'll need to turn left, move forward, and toggle the switch. We're doing the reverse pattern of these gems here. You can see they're at the end, whereas the gems are at the start. So we're going to turn left, move forward, and then toggle that last switch. Now, what about the cases of when we're blocked? Okay, so if we were to run this code right now, we'll see that we'll move forward. We're going to check we're on the gem, and we're eventually going to get to the end of this platform here, and we're not going to be able to progress any further. So should we, move forward a certain amount of times? No, let's use our condition of while we're blocked or while we're not blocked. Because look, we're basically not on the open switch. We're going to be moving forward forever. So Byte's just going to be stuck in this loop of almost falling off. So how can we handle this? Well, we definitely need to be able to handle the case of when our character is blocked. So we can handle this in a few ways. We can say, okay, while right isn't blocked, move forward. If they're not blocked on the right, turn right. Otherwise, you can turn left. So let's go ahead and handle this, and we can talk through it as we code. So while we are not blocked, so the exclamation point, is on gem, is blocked, we're going to go ahead and move forward. So anytime we're not blocked in front of us, we're going to move forward. We can then do our if. So if we are not blocked on right, we're going to go ahead and turn right. Then we can say else for all those other scenarios, we're going to need to turn left. I think this looks pretty good. The only thing is on close switch, we would need to make this an else if. So it can check the gem first and then check the close switch. So we're going to be looping through this, and now we have conditions to look at, when we're not blocked, move forward. If we're not blocked on the right, we can then turn right. If we are blocked on forward and blocked on the right, we're then going to turn left. You can handle this algorithm and these decisions any way you wish. There's oftentimes multiple solutions for the same problem, so your encode may look a little bit different than mine. Go ahead and also change this to the step through so we can track our changes as we go. Okay, here's where we're going to be blocked on the right. We're going to then turn left. You could have done it with the ampersands to check for those different conditions. This is just the way I'm choosing to handle it. So we're not blocked, we're going to be moving forward. Okay, we're finally blocked in front of us. Are we blocked on the right? Nope, we're then going to turn right. We're doing our collect gem. So we're going to move forward. Still not blocked. Okay, we're finally blocked. Are we blocked on the right? There we go, we're moving forward. This is a pretty cool way to demonstrate algorithms. It's one of those things that you've been creating algorithms this entire time without really having a term or name with it. It's about using all the tools in your toolkit to solve a problem. And even in multiple scenarios, like with the other puzzles, no matter what the landscape looked like, we were able to solve those issues. But by looking at these different conditions where byte is, okay, are we blocked? Are we blocked on the right? Right? We're kind of evaluating every single step of the way in order to make the best decision, whether that's through while loops, whether it's through if else statements, etc. Those different conditions, logical operators, you're able to make those decisions and have the best output. All right, we're collecting the last couple gems, and then it's the moment of truth when we're finally on a closed gem, or sorry, closed switch. Can't be on a closed gem, that doesn't make sense. Okay, we're going to be blocked here. Are we blocked on the right? There we go. We're going to turn left, and then we should exit the while loop because we're on the close switch. And that's it. We have completed Learn to Code number 1. You are now officially, apparently, a coding master. You can do a little dance if you want to. I don't think I'll do one. So we've come a long way in Learn to Code 1, but we're not done yet. In the next episode next week, we'll be taking a look at Learn to Code 2. You can also press on the link at the end here in order to get it. I already have it downloaded. We'll be tackling variables in Learn to Code 2 next week. So congratulations on completing Learn to Code 1. If you missed any of the lessons along the way, there is a playlist linked in the description below. Otherwise, dream big, code bigger, and give yourself a pat on the back for making it this far, and great jobs conquering algorithms. We'll see you in the next one.